This is another update on the 3D printed Enigma machine. On the main part here, I've just tidied things up a little bit since last time. I've just shortened the shaft there, and I actually discovered a small problem, which was my the levers of the pawls with the, take this out, the little weights that I have in here, these little circular brass weights, were actually a little bit too big, and they were hitting the edge of the ring there, and so the pawls weren't going all the way up. They were going up enough to get the rotors to move around, but not exactly right. So I fixed that up. I just machined them a little bit smaller. So if we put this back in, it's a little bit awkward getting everything into place. There we go. So the rotors now step much more cleanly, as you can see. The other thing I've been doing is figuring out how to do the keyboard. Now, the original Enigma machine used sort of little metal contacts that the keys pressed on. It was quite a large number of these contacts, and there was no easy way I could make those. So what I decided to use was these, which are little micro switches. So these are the smaller size ones. They come in various sizes. I assume they're standard sizes. I had a look and most of them seem to be around the same size, but these are the sort of slightly smaller than the standard size ones. And what I started doing was figuring out how I was going to get the shaft that the key presses on to press on the micro switch. So what I came up with is, this is a base plate. So instead of printing out the whole thing, which takes forever, I printed out these little test pieces. And you can see what I've done here is made, this is basically the bottom plate that sits above the seesaw piece here, and the keys go through it, press through it like that. So what I've done is I printed in these little pockets, and those are exactly the right shape for the micro switches to be a press fit into. You can see the switch moves there. And then the shaft will go through the hole. So to actually actuate the switch, I started playing around with little cams. So I started with things like this. The idea being that the switch would sort of ride over the cam, but they didn't work too well. So I've just dropped it. Let's see. Then I started making cams that are more like this. It's a bit hard to see, but on this shape basically, let's see. This is one of my earlier test pieces. You can see it's circular with a flat on it, and the flat has a little bump, and that's the cam part. So that presses through the shaft of the key. I should also mention that I decided, instead of 3D printing the keys, I'm going to use aluminium for the shafts. You can actually print long skinny key-like shapes. That was a test print I did. But the problem with those is they can be quite weak because of the layers of plastic, and also they're fairly rough. Don't know if you can hear that, but it's sort of scratchy. It's not a smooth surface because of the way the plastic gets layered down. And I was just a bit worried that these wouldn't be strong enough and they wouldn't be smooth enough when you're actually pressing the key through the little key mechanism. So I ended up buying a whole lot of this 1/4 inch aluminium, and I'm going to make all the key shafts out of that. It's also very handy for making standoffs because I need quite a few of them to hold pieces up. So I'll be using it for that as well. But you can see I printed the cam, and the cam rides over the little roller on the micro switch. So if we imagine this goes in there, and then this goes through the hole, you can sort of see as the cam comes down, it pushes on the switch. Now that works fine. The problem is this can rotate. There's nothing stopping it from rotating. So what I ended up doing is, take that apart, coming up with a different shape for the cam. This was my first attempt, but it doesn't quite work. What I ended up with is something like this. So this is the same sort of cam. You can sort of see the ramp in the bottom there, but it's got these sort of side pieces on it. And now what they do is, if we push that through there, when this goes through the hole, these side pieces fit over the edges of the micro switch. So the micro switch itself will stop this from rotating. This can then go up and down and actuate the switch, but it can't turn. The reason you don't want it to turn, of course, is because then all the letters on your keyboard would end up spinning around. So that's how that works. What I did was I actually printed a single, effectively a single key example. So you can see how that actuates the micro switch. The other thing is there's actually the hole in the top that the shaft fits through. There's actually a slightly bigger hole in the bottom, and a spring is going to go in there. I don't have the springs yet, but what will happen is there will be a spring in this piece between here and here, and when you press the key down, of course it'll be sprung loaded, so it'll just pop back up again. This little foot is what presses down on the seesaw part, so that'll press down sort of like that. The thing I have to do is get the positioning of the ramp on the little cam exactly right, so that as the key comes down, it presses down the seesaw, and then after the rotors have moved, it then actuates the micro switch. And I can do that by varying the size of that the ramp on that cam. So because there are 3 rows of keys across the keyboard, I'm going to need 3 different cam models to get that right. So what I'll do is I'll build the keyboard and I'll experiment to get the size exactly right. The other thing I've done is printed the key tops, and this one's just got a little piece of white paper in the top there, and it's a bit hard to see on the film, I think, but it's actually got a clear plastic window. Now what I did for those is, if I can move the camera, I made use of this, which is a little tiny laser cutter I made. It's a bit tricky to see. This is the laser here. These are actually DVD mechanisms out of DVD drives. And this is a tiny, tiny little laser cutter. And put that down. I use that to, it's very difficult to see it because it's clear, of course, but I use that to cut little windows out of some clear plastic. You can see the lasers cut the holes out of those. Then I actually discovered something else. I had a better idea. I've got some of these. I'm not even sure you're going to be able to see this, but these are actual glass windows. Now somebody may know what those are from. They're actually microscope cover slips. So these are very, very thin glass, and it turns out they come in different diameters. And one of the diameters you can get is 12 millimeters. And 12 millimeters just happens to be more or less the size of the window I need for the top of the key. So the actual key piece is made in 2 parts. There's a base. These are actually misprints, but there's like a little base ring and then the little bottom part, and the little window goes into there with the label, and then this basically is a push fit, and it sort of sandwiches it all together. And then that is a push fit onto the top of the key. So that's how that'll work. The cam will stop the keys springing up too far, and to stop the keys being pushed down too far, because this cam is just a tight fit on the shaft. It's not actually held on in any way, but I don't need it to be. I just need it to be able to hold its position, because what I'm actually going to do is, let me tilt this down, let me rotate this around a little bit. When I print the base that the keyboard sits on, I'm actually going to print a little stop so that this will only go down so far, and then the key will press down onto that, and the stop will stop it going any further. So it's a mechanical stop, and that basically just stops being able to do that, slide the key through the cam too much. So I'm hoping that with a good tight fit there and a nice free motion, that should work quite well. So what I've been doing is actually printing the main bit of the keyboard. Oh, I should point out there's three pieces to the keyboard. There's the base, which is this piece that'll hold all the micro switches, and there's actually this top piece which has all the holes in it and these little pillars. And the way they work is they will press on the top of the switch, and that holds the switch in place. And then this piece goes, this is a section of keyboard. This was my test section. It's a key with a spring. That spring doesn't fit in the cams, unfortunately. But this is the profile of the keyboard. And I just printed out just a short section to see how that would work. And what I've done is I've printed out a bigger section. The thing that's printing in the background right now, which is just over there on the printer, is the main keyboard, and that's taking something like 36 hours to print. So if we look at this is the base plate and the little piece that has the things that hold the switches in place, and I've kind of got one switch in there at the moment just to see how it works, and that's got a cam on it so you can hear it clicking. That will end up fitting over the top of that, so that when the keys press down, they will actuate on the keyboard mechanism. So, like I say, this is just a test. The whole keyboard will sort of sandwich together like that. I am a little bit worried that it might be flexible in the middle. I may need to put another support in the middle. The original Enigma machine actually has a support in the middle there, so chances are I will need that. But we'll see how it goes. But that's more or less how that's going to go. This keyboard, we'll take a closer look at the keyboard printing. So this, you can see it printing away there. That's the full keyboard. I've used quite a low percentage of infill, that's 10% infill, just to make the thing a bit lighter and make it so it doesn't take too long to print. But once that's done, I should be able to then look at assembling the actual keyboard. I do need to machine up all the little shafts and things out of the aluminium, so I'll have to put all those, make all those on the lathe, and I need to wait until the springs arrive. They're on their way from China. So this was actually quite a big bit of work to design all this from scratch, just matching the existing keyboard and keyboard shape. But I think that should work. Like I say, with a bit of extra support in the middle perhaps, I think that'll be fine.